learning so many new things from the other friends of yours who will be presenting in the due course. And I request all the members of the jury to please encourage the young minds, because I believe each one of them, they are unique in their own way. So they must have toiled hard to put up today's show. So they should be encouraged and inspired by every possible means. At the same time, it's a gentle reminder to all the teacher in charge working at different exhibition halls. Please ensure that your recording mode is connected. Thank you so much. All the best, students. Put up a great show. Thank you so much, everyone. Now the children can move to their respective breakout rooms.
Children's Hotel.
Good afternoon, children.
Good afternoon, ma'am.
Good afternoon, ma'am.
Okay, are you all ready?
Yes, ma'am.
So everybody, welcome to the grand exhibition of our school. And the name of the exhibition is AllyTech. All are welcome to this exhibition platform and virtual platform. So we are going to start it shortly within 2 minutes. Welcome, judges. Anadi sir, welcome to you. Yes, Anadi sir is there. Anadi Charan Sahu, sir is from IFCO DAV. Sir, you are welcome to the annual exhibition. And Sanjay sir, you are also welcome to the annual exhibition of our school.
Yes, ma'am. Thank you.
So our tiny tots have performed very nicely. We hope that they will definitely do well and present very nicely. So let us start. Shall we start, sir?
Yes, yes.
Shall we begin, sir? We will dictate the name and code of the children, and by the time you have to note it down. The name and code of the children, you have to note it down in the judgment seat, and they will present their exhibits one by one. Accordingly, their names will be called from here. So let us start. All the best to everybody. The first participant for the sub-junior group is Arya Pratap Sahu. The code number is 230. Name of the project is 3D shapes. Arya Pratap, are you ready, beta?
Yes, ma'am, I'm ready.
Okay, so begin, start.
Good morning. We all live in a three-dimensional world. Everything we can see or touch have three dimensions that can be measured by lead, with width, and its height. Examples of 3D shapes are cuboid, cube, pyramid, cone, sphere, cylinder, etc. Cylinder. Let us know about details and properties. A cuboid has 6 faces, 8 vertices, and 12 edges. A cube has 6 faces, 8 edges, and 8 vertices and 12 edges. The examples of a cube are ice cube, dice, etc. This is a pyramid. There are many pyramids, but I have chosen two. This is a square pyramid. It has 5 faces, 5 vertices, and 8 edges. This is a triangle.
Request Arya Pratap, please mute yourself. Now you unmute. If there is some background noise, please close the door and proceed.
Okay.
Okay.
Good morning. We all live in a three-dimensional world. Everything we can see or touch have 3 dimensions. 3D shapes. There are 6 3D shapes. One cuboid, second is cube, third is pyramid, fourth is cone, fifth is cylinder, and sixth is fifth is sphere, and sixth is cylinder. Let us know about a cuboid. Cuboid has 6 faces, 8 vertices, and 12 edges. This is a cube. It has 6 faces, 8 vertices, and 12 edges. The examples of a cube are ice cube, dice, etc. This is a pyramid. There are many pyramids, but I have chosen only 2. This is a square pyramid. It has 5 faces, 5 vertices, and 8 edges. This is a triangle pyramid. It has 4 faces, 4 edges, and 6 vertices. This is a cone. It has a vertex, a curved face, and a flat surface. The examples of a cone are birthday cap, etc. This is a sphere. It has no faces, no edges, no sides, but we should know that it has one surface. This is a cube. This is a cylinder. It has 2 edges, 2 flat surfaces, and a curved surface. The example of a cylinder are a pencil, and gas cylinder, etc. Ma'am, let's know about the summary. It is important for all of us to know about 3D shapes. Learning 3D shapes not only helps identify and organize visual information, but it will help us to learn skills in other areas. Thank you. Have a nice day. Ma'am, I have completed.
Okay, I would request the judges to ask some question to Aryabrat. If Arya Pratap, sorry.
Thank you, Arya Pratap. Very nicely you have presented. You are which class? Arya Pratap.
I am from class 3.
Oh, excellent. Class 3. Class 3, you are nicely representing the 3D shapes. Okay. Okay, that means you have shown one square-based pyramid. Yes? Can you tell me how many vertices are there in square-based pyramid? In square-based pyramid, how many vertices? How many faces?
There are 5 vertices.
How many
5
faces?
faces in.
Good.
There are 5 faces in.
Yes. Can you tell me the outer faces? What is the shape of the outer faces? What is the shape of
There are 4
shape?
rectangular faces. Sir, there are 4 rectangular face and a square face.
No, 4 rectangular faces are not there. In square pyramid, what you are holding, that are triangular faces are there. You see all the outer faces. You see the lateral faces. It is just like a triangular knot. Yes? Yes, very good. Keep it up. Nicely you have done.
Sir, I pronounce the triangle to rectangle.
Okay. No problem. You know the triangle, na? Okay, thank you.
Okay, good.
Thank you.
Very good.
Arya Pratap, thank you for your nice presentation. I came to know that you are of standard 3, but the presentation was very nice according to your age group. Now, just triangular pyramid.
Yes, sir.
Is there any other name for that? Can we? Okay. Thank you. This much.
Other name is tetrahedron, Arya Pratap.
Yes.
Okay, so you should know that. Thank you. Have a wonderful presentation. You have presented very nicely. Okay, so our next participant is Tejas Das, and the code number is 231. The project name is Polygon and its angles. Tejas, are you ready, beta?
Yes, ma'am. Can I give
Okay, all the best. Dear parents, please mute. Just mute. Just first mute. Get everything ready, then you start.
Yes, ma'am.
Okay. Good.
I am going to do a presentation on angles and polygons. Minimum 3 lines or more with each other. The Greek word poly means many and gon means angle. Some real life examples of polygons are the tiles we walk on are square shape, the walls of a building are square or rectangular in shape, triangle, square, rectangle are examples of polygon. Now let's learn what are angles. Angles are formed when two lines intersect at a point. The measure of the opening between these two lines is called an angle. It is denoted by using the symbol angle. Angles are usually measured in degrees. So this is the symbol of an angle. Now let's learn about different types of angles. So firstly, we have interior angles. The interior angles are formed between the adjacent sides inside the polygon. So as you can see here, I have made an example. So this is interior angles and exterior angles. So as you can see, the tick marks means the interior angles. So as you can see, we have 3 interior angles. Now let's learn about exterior angles. Each exterior angle of a polygon is formed by extending one side of the polygon, either clockwise or anti-clockwise. And then the angle between that extension and the adjacent side is measured. So as you can see here, the cross means the exterior angle. 3 exterior angles, 1, 2, and 3. So as you can see here, all angles are A, B, C, D, E, F. The blue color angles represent the interior angles, and the yellow colored angles represent the exterior angles. Now let's learn about regular and irregular polygon. The difference between regular and irregular polygon is given as regular polygon having definite pattern and irregular polygon having not definite pattern. The difference between the criteria of difference between a regular polygon and irregular polygon are length of sides, measurement of all interior angles, and measurement of all exterior angles. So the regular polygon makes all of these differences equal, while the irregular polygon makes all of these differences unequal. Now let's learn about triangles, also known as trigon. The sum of all interior angles of a triangle add up to 180 degrees. So that means 80 plus 70 plus 30, which is equal to 180 degrees. Now let's learn about quadrilateral having 4 sides. As you can see here, I made an example having 4 sides. A quadrilateral having 4 sides. The sum of all interior angles of a quadrilateral is 360 degrees. So there are 2 triangles in a quadrilateral. As the sum of interior angle in a triangle is 180 degrees. So the sum of interior angle in the quadrilateral is 2 into 180 degrees, which is equal to 360 degrees. Similarly, in a pentagon having 5 sides, there are 3 triangles as shown in the given figure. As the sum of interior angle in a triangle is 180 degrees, so the total interior angle in a pentagon is 3 into 180 degrees, which is equal to 540 degrees. Now we have a hexagon having 6 sides. A hexagon can be divided into 4 triangles, as you can see here. So that means 4 into 180 degrees, which is equal to 720 degrees. Now we have a septagon having 7 sides. Now a septagon can be divided into 5 triangles. So 5 into 180 degrees, which is equal to 900 degrees. But if the polygons having more sides, for example, a decagon having 10 sides, or an octadecagon having 18 sides, then it is difficult to draw all the triangles within it and to calculate the total interior. Here lies the beauty of mathematics. It has a simple formula that is sum of interior angles in a polygon is equal to n minus 2 into 180 degrees, where n is the number of sides. Then the task becomes very easy. If it is a triangle, then n is equal to 3. So the total interior angle is 3 minus 2 into 180 degrees, which is equal to 180 degrees. If it is a pentagon, then n is equal to 5. So the total interior angle is 5 minus 2 into 180 degrees, which is equal to 540 degrees, and so on. Mathematical tools are also helpful to find each angle if it is a regular polygon. The formula is n minus 2 into 180 degrees by n. If it is a triangle regular, then each angle is 3 minus 2 into 180 degrees by 3, which is equal to 60 degrees. If it is a pentagon regular, then each angle is 5 minus 2 into 180 degrees by 5, which is equal to 108 degrees. In this way, mathematics is very simple with its tools and formulas. Thank you for listening to my presentation.
Thank you, Tejas. Now it's over to judges.
Tejas.
Hello. Yes, sir.
Very good. Nicely you have presented your project. What is angles and polygons? Yes.
It's angles and their polygon.
Yes. A pentagon has how many sides, beta?
Pentagon has 5 sides.
Okay. How many exterior angles are there in a pentagon?
There are 5 exterior angles.
5. Very good. Can you tell me what is the sum of the 5 exterior angles of a pentagon?
That is 360 degrees.
Very good. Very good. Nicely you have told. And madam.
Okay.
Thank you.
Yes,
Tejas,
sir. Thank you, Tejas. Next participant. Sir, Sanjay,
Yes.
sir, do you have?
Yes, ma'am. Thank you, Tejas. And can you tell me what is the minimum number of sides to make a polygon?
3 lines.
Very good. And what is the name of that polygon?
Triangle.
What is the, if I will say it is a regular polygon of 3 sides, what is the special name for that? Suppose it is a regular polygon of 3 sides, I told. It is a triangle, sure. You told a triangle, but is there any special name for that?
All 3 sides.
Any special name?
I will tell.
It's an equilateral triangle. Okay. Thank you. Thank you. Okay, ma'am. Proceed. Okay. Thank you.
Next participant is Ansul Ishan. The code number is 232 and name of the project is multiplication calculator. Ansul, are you ready?
Yes, ma'am.
Okay. All the best.
Okay, ma'am. Good afternoon, teachers. I am Ansul Ishan from Standard 3. This is my project. Welcome to our exhibition, Technology and its Impact on Society and Environment. This is my project, Multiplication Calculator. Can I share my screen?
Yes, of course.
Okay, ma'am. What is multiplication calculator? Multiplication calculator is a new way for calculating without using mobiles, computers, and calculator app. As you all know, multiplication has a great role in our society. Starting from marketing to investment, it plays a vital role in everyone's life. Due to the development in technology, nowadays, many apps are also there for children like Math Bingo, Suzuki Monster, Monster Math, Tower Math, and many more. This is the image of the great mathematician John Napier, who invented the multiplication calculator, which is also known as Napier's board. This is my project. Don't be scared by the name. Actually, Napier's bones are a device used to calculate multiplications with simple additions. The bone one on the left, the extreme left, that is this one, performs the role of a guide to show you the multiples on the top digits of each row, each column. So now let us look at how exactly it works. Let us do some problems. Let us take 132 multiplied by 4. So I will take out all the bones except I will keep the bones 1, 3 and 2. So first we will come to the row of 4. As you know, because we are multiplying with 4. So we will look it diagonally and add it. 8, 2 plus 0, 2, 4 plus 1, 5, and 0. So we will not add 0. As you all know, 0 has no value in the left. And the answer is 528. So now let us take another multiplication. 1327 multiplied by 45. We can also do by 2 digits. So we will come to the row of 5 as the 5 is at one's place. So we will add it diagonally. 3 plus 0, 4, 3. 5 plus 1, 6. 5 plus 1, 6. And 0. And now we'll come to the row of 4. And we will put a cross as usual multiplication. 8. Here it is 8 plus 2. We will keep 0 and bring 1 here. 2 plus 1, 3. 4 plus 1, 5. And now we will add it. And the answer is 59,715. Thank you.
I am requesting the judges to ask some question, give some question to solve.
Console.
Yes, sir.
Very good. You have presented, and you have multiplication also you have done very tricky way. Can you tell me if 10 you will multiply 8 times?
Yes,
10
sir.
into 10 into 10. How many 0 will come?
Sir?
10 you will multiply 8 times. 10 into 10 into 10, 8 like this, 8 times if you will multiply, how many 0 will come?
Ma'am, sir, 1 0.
You will multiply 10 into 10 into 10 like this, 8 times you will multiply 10.
Yes, sir.
Okay, 10 into 10 is how many 0 will come?
Sir, 2 0.
2 0. 10 into 10 into 10, how many 0?
Sir, 3 zeros.
Like this, if you will 8 times you will multiply, then how many zeros you will get?
Sir, 8 zeros.
Very good, very good. Thank you, thank you. Madam.
And Anshul.
Yes, sir.
It was a nice presentation. So can you again show me that Napier bones and multiply 59 into 12?
Okay, ma'am. Okay, sir. Sir, can you say the number again?
59 into 12.
Okay, sir.
Small one I give it.
59 into 12. So first we will come to the row of 2. 8. 0 plus 1, 1. And 1. So now we'll come to the row of 1. And we'll put a cross as usual multiplication. 9. 5 plus 0, 5. And 0. And now we will add it. And the answer is 708.
Okay, thank you.
Welcome.
Thank you, Anshul. Thank you very much. Now, next child is Alia Priyadarshini, class 3.
Yes, ma'am.
Code is 233, Secret Sum Puzzle. Name of the project is Secret Sum Puzzle. Alia, start.
Good afternoon, everybody. I'm Alia Priyadarshini from class 3. Today I'm going to present a wonderful mathematics project on the theme Technology, Society and Environment. The name of my project is Secret Sum Puzzle. In the puzzle, there are 3 dialing wheels with 12 sectors each. Each sector consists of 1 picture and 1 number. Would you like to solve this puzzle, ma'am and sir? Now, I will solve this puzzle very quickly. 5 plus 5 plus 2 is equal to 12. 2 plus 1 plus 9 is equal to 12. 4 plus 0 plus 8 is equal to 12, etc. If you see this puzzle closely, you can see 3 different kinds of pictures. Like, tree indicates environment, human beings indicate society, factory indicates technology. The puzzle will be solved when the sum of number in each sector will be same for all of the 12 sectors. With the image of society, environment, and technology. The puzzle depicts the interdependence of society, environment, and technology. While this math puzzle will be solved, it will be pictorially align nature, technology, and human being. Finally, with the combination of technology, society, and environment, we can find out the secret number. Here is our secret number. Our secret number is 12. Thank you. Have a great day ahead.
I am requesting both of the judges, please ask some question related to the project.
Alias.
Yes, ma'am. Yes, sir.
Very nicely you have presented Secret Sum Puzzle. Yes.
Thank you, sir.
Can you tell me any 2 applications where we can use this type of puzzle?
Yes, sir.
Any 2 application, can you explain? Any 2 application where we will use this type of secret sum puzzle? Any application in our day-to-day life? Okay, okay. Your sum is coming how much when you are showing the sum? Total sum is coming how much? Okay. Can we take any number, other number, which will come the same sum? Now only 12 is fixed.
Yes, sir.
Only 12 fixed. Any other number you cannot take?
No, sir.
Okay. Okay, thank you. Thank you, Alias.
Welcome, sir.
Thank you. Very nice.
Thank you, Alia. Thank you, Alia. No questions to ask. Okay, thank you.
Next child is Joyce Kumar Naik, class 3. Code is 234. Here, the name of the project is Circle and Plane and Solid Shapes.
Good afternoon, everyone. My name is Ashwani from class 3B. Today, I am here to present you my maths project on 2D and 3D shapes. So let's start it. Technology provides additional opportunities for learners to see and interact with mathematics concepts. The student can also explore and discoveries with plays and games and digital tools. So first, I am going to show you my my automatic electronic machine to draw a 2D shape called circle, which is a plane shape. So first, I need a center on a paper to draw it. A center is a midpoint of any object. So first, I have to keep the pin here. Then I have to on this button. Then it will start moving. So now you can see I have drawn two circles with the same center, which is called as concentric circles. My second model is environmental model made up of 2D and 3D shapes. As well as all we know that 2D shapes are also known as two dimensions with length and breadth. Examples: triangles, circle, squares, and rectangle. The 3D shapes are also known as three dimensions with length, breadth, and width. Examples: cubes, cuboids, sphere, and pot and cylinder. So at last, I want to say you that the shapes are very important concept of an object. Thank you. Have a great day.
I'm requesting judges to ask some questions related to shapes.
Thank you.
Yes, yes, sir.
Good afternoon, sir. I hope you are fine.
Sir, Anand sir asked.
Okay, thank you, sir. अच्छा, perhaps you tell me a square is a plane figure, yes? Two-dimensional.
Yes, sir.
How many diagonals you can draw in a square?
Sir, two.
Two diagonals. Very good. Thank you.
Joyce.
Yes, sir.
Just I saw that you were drawing two circles. And you told that this is two circles having the same center. What is the name you told that?
The concentric circle.
Concentric circle. And what is the region bounded by the two concentric circle? What is the name of that region? The region between the two concentric circle.
Sir, I don't learn that.
Okay. Thank you. Beta, this is called a ring. The region between the two concentric circle is called a ring. Okay. Thank you, beta.
Thank you, sir.
Okay, thank you. So nice.
Next child is Jignesh Lenka 3. Code is 235 and topic is Vedic mathematics multiplication.
Good afternoon, everybody. Myself, Jignesh Lenka, class 3, section B, is going to present about my topic, multiplication made easy by Vedic mathematics. Ma'am, can I share my screen?
Yes, you can share.
multiplication by Nikhilam Sutra. By knowing simple addition and subtraction of single-digit numbers and the multiplication table up to 5 times 5, we can prepare the multiplication and also perform multiplications involving bigger multiplicants and multipliers. The sutra used is Nikhilam Navataskaramam Dasataha, which means all from 9 and the last from 10. So, here are the examples of two-digit multiplication. First example, multiply 93 by 94. In this case, our base is 100. So, I took 93 and 94 at the left-hand side. Now, we will subtract 93 from 100.
Jignesh, go slowly. Go slowly.
Which is equal to less 7, and 94 from 100, which is equal to less 6. Now, we will do cross subtraction. 93 less 6 is 87, while 94 less 7 is also 87. In Vedic mathematics, the result of cross subtraction and cross addition are always the same. Now we will vertically multiply 7 and 6, which is equal to 42. So the final answer is 8742. Second example, multiply 13 by 12. In this case, our base is 10. So we will took 13 and 12 at the left hand side. But as we know that 13 is bigger than 10, so we'll put plus 3, and 12 is bigger than 10, so we'll put plus 2. Now we will do cross addition. 13 plus 2 is 15, while 12 plus 3 is also 15. Now we will vertically multiply 3 and 2, which is equal to 6. So the final answer is 156. Third example, multiply 89 by 95. In this case, our base is 100. So we will took 89 and 95 at the left hand side. Now we will subtract 89 from 100, which is equal to less 11, and 95 from 100, which is equal to less 5. Now we will do cross subtraction. 89 less 5 is 84, while 95 less 11 is also 84. Now we will vertically multiply 11 and 5, which is equal to 55. So the final answer is 8455. Fourth example, multiply 17 by 15. In this case, our base is 10. So we will took 17 at 15 at the left hand side. Now, but as we know that 17 is bigger than 10, so we'll put plus 7, and 15 is bigger than 10, so we'll put plus 5. Now we will do cross addition. 17 plus 5 is 22, while 15 plus 7 is also 22. Now we will vertically multiply 7 and 5, which is equal to 35. But as we know that 35 is bigger than 10, so we will take 3 to the left hand side and add it. 22 plus 3 is 25. So the final answer is 255. Now I am going to show you.
Jignesh, stop.
Yes, ma'am.
Completed, or you are showing something?
Ma'am, completed. Now I am doing an example.
You are giving one example. Acha, okay.
$105 multiplied by 106. In this case, our base is 100. But as we know that 105 is bigger than 100, so we'll put plus 5. And 106 is bigger than 100, so we'll put plus 6. I will do cross addition. 105 plus 6 is 111, while 106 plus 5 is also 111. Now we will vertically multiply 5 and 6, which is equal to 30. So the final answer is 11,130. Thank you.
Requesting judges to give some question to solve. Give some question to Jignesh.
Very good, Vignesh.
Thank you, sir.
You are a mini mathematician. Very nicely and a shortcut way you have done all that. That means bigger number multiplication. A simple multiplication I am giving you. Do it on your board. 17 into 17.
Yes, sir. 17 into 17.
Yes.
In this case, our base is 10.
Yes.
But as you know that 17 is bigger than 10, so we will put plus 7, and also 17 is bigger than 10, so we put plus 7. Now we will do cross addition. 17 plus 7 is 24, while 17 plus 7 is also 24. Now we will vertically multiply 7 and 7, which is equal to 49. So the final answer is 2449.
No.
What you have done, Vignesh? If 17 you multiply 2 times, 17 into 17, will it come 4-digit number? How many digit number will come? It will come 3-digit number. Yes?
Yes, sir.
Okay. Okay, you do it again. Thank you. Thank you. Thank you. Okay, you have tried a lot. Thank you, madam.
Jignesh.
Yes, sir.
You well done. This is but one thing you did. What mistake you did, you know? That is 4 plus this 4 should be carried out to the left side and 4 will be added with 4, isn't it? That will be 8. You are taking. You have taken the 7. What is 10 base taken, na?
Yes.
So this will be 4 should be isn't it? You know that a lot of some more practice is there, but the project was very good. Okay, one more multiplication can you do? 99 into 102.
Yes. 99 into 102. In this case, our base is 100. So we'll subtract 99 from 100, which is equal to less 1. And 1, but as we know that 1 is then 100, so we'll put plus 2. Now we'll do cross addition and cross subtraction both in this case. And 99 plus 99 plus 2 is 102, while 102 plus 1 is also 101. Now we'll vertically multiply 2 and 1, which is equal to 2, but in this case our base is 100, so we'll put 10. So the final answer is 10,102.
No, better. Can you tell me what is the ones place or unit place when we will multiply 99 into 102? What will be the unit place or ones place? Which digit will be there? 99 into 102. Just you tell me. Not necessary to tell me the answer. Just you tell me what will be the unit place. Which
sir,
digit?
89. Sir,
okay,
sir, 98.
I am asking the ones place digit of the product of 99 and 102.
So, sir, it will be 98.
Okay. But ones place means only ones place I'm asking means 8 it is. 98 means it is you are saying. Okay. Thank you. Just a very small child you are, but you have done a lot of things. Okay. Thank you. Thank you, ma'am.
Sahu, 3C. and code is 236, 2D net to 3D shape.
Can I start?
Yes, all the best, start.
Respected teachers, judges, and my dear friends. Good afternoon, everyone. This is Abhira Sahu from Class 3, Section C from DAV Public School in Adelaide. Everywhere in our surrounding, we are dealing with some shapes. It may be two-dimensional or three-dimensional. Two-dimensional shape means its length and breadth. Example of two-dimensional are circle, triangle, rectangle, square, etc. It do not occupy space. Whereas three-dimensional means it is length, breadth, and height. The example of three-dimensional are cube, pivot, cylinder, cone, sphere, etc. It occupies some space. Today I am going to convert 2D land to a 3D solid shape. This is my activity. It is called a pop-up activity. But first, we have to know what is a net. A net is what a 3D solid object would look like if it is open out flat. You can see now, this is a 2D net of a cube. It has 6 identical surfaces. Now it is in flat surface. Now I will convert it into a cube. See, this is a cube now. It has 6 surfaces, 12 edges, and 8 vertex. The example of cube are Rubik's cube, sugar cube, ice cube, dice, etc. This is the 2D net of a cube. The 6 rectangular surfaces. Now I will convert it into a cube. See, this is a cube now. The 6 surfaces, 12 edges, and 8 vertices. The example of cube are matchbox, geometry box, eraser, etc. Similarly, we can explore the surface of cone and cylinder. This is a 2D net of a cone. Now I will convert it into a cone. See, this is a cone now. It has 1 vertex, 1 edge, and 2 surfaces. 1 curved surface and the plane surface. The plane surface is circular in shape. The example of cone are birthday cap, funnel, ice cream cone, etc. This is a 2D net of a cylinder. Now I will convert it into a cylinder. See, this is a cylinder now. It has 3 surfaces. 1 curved surface, 2 plane surface. It has no vertex and it has 2 edges. The plane surface in circular is same. The example of cylinder are powder can, glue, pipe, tube light, etc. Hope you understand the concept of 2D net to 3D solid shape. It's really helped us to explore the surface of 3D shapes. Thank you. Have a wonderful day ahead. So done.
Excellent, Abhiraz. Very good.
Thank you, ma'am.
So now it's over to judges.
Thank you, Abhiraj. Very nicely you have presented. You have prepared this cube and cubed.
Yes,
you have
sir.
prepared your own.
Yes, sir. My mother
Helped you. Very nice. Very nice. Okay, let me see a cuboid. When you are taking a cube has how many vertices?
8 vertices.
How many faces?
6 faces. 6 identical faces.
Okay. How many edges?
So 12 edges.
If you will take cuboid, how many faces and edges and vertices?
8 vertices, 12 edges, and 6 rectangular surfaces.
Okay. So what is the difference between these two, cuboid and cube?
In cube, all sides are equal, but in cuboid, the opposite sides are equal.
Yes, very good. Excellent, excellent. Very nicely you are presented, and conceptually you are also clear. Very good. Thank you.
Abhiraj.
Yes, sir.
Do you know what is the what is a hollow cylinder? The cylinder you told, if the cylinder was, I will cut another one cylinder from one cylinder, isn't it? Suppose one cylinder is there, eh? So I will cut another one piece of cylinder out of that. Then the remaining one will be called which type of cylinder it is?
The cylinder.
Okay, it's okay, not strong. Okay. Thank you, proceed. Thank you, ma'am.
Next is Akhilesh Mishra, and code number is 237, units for measuring length. Akhilesh, are you ready?
Yes, ma'am. Okay. Good afternoon, judges and my dear friends. I am Akhilesh Mishra from Standard 3, Section C. I am glad to stand here and I want to present a model of unit of measuring length. Before I start my presentation, I will tell about measurement. Measurement is the quantification of an attribute or an object which can be compared to measure other objects or events. Length is a distance of unit. We know that the standard unit of length is meter and the greatest unit of length is kilometer. Similar measurements are decimeter, centimeter, hectometer and millimeter. Let's start my working model of measurement. When we are moving from kilometer to millimeter, we are multiplying by 10. And when we are moving from millimeter to kilometer, we are multiplying by 1 by 10. Let's see how my model works. My first example is 1 kilometer, how much meter? So we will move from kilometer to hectometer by jump of 10. It will be 10. Now we will move from hectometer to decameter by jump of 10. It will be 100. Now we will move from decameter to meter by jump of 10. It will be 1000. Yay! We got the answer. 1 kilometer, 1000 meter. So my second example is 1 meter, how much millimeter? So we will move from meter to decimeter by jump of 10. It will be 10. Now we will move from decimeter to centimeter by jump of 10. It will be 100. Now we will move from centimeter to millimeter by jump of 10. It will be 1000. Yay! We got the answer again. 1 meter equal to 1000 millimeter. So now we will do from lower to higher units. My first example is 1 meter, how much kilometer? So we will move from meter to decameter by jump of 1 by 10. It will be 1 by 10. Now we will move from decameter to hectometer by jump of 1 by 10. It will be 1 by 100. Now we will move from hectometer to kilometer by jump of 1 by 10. It will be 1 by 1000. Yay! We got the answer again. 1 meter equal to 1 by 1000 kilometer. So my second example is 1 millimeter, how much decimeter? So we will move from millimeter to centimeter by jump of 1 by 10. It will be 1 by 10. So now we will move from centimeter to decimeter by jump of 1 by 10. It will be 1 by 100. Yeah, we got the answer again. 1 millimeter equal to 1 by 100 decimeter. Now in this way, we can convert capacity, weight, length, and etc. Thank you. Have a nice day.
Good. Now it's over to judges.
Achilles,
Yes, sir.
very nice. Who has prepared this model?
Ma'am, sir, my mother and me.
Who has given the idea to select this project?
Ma'am, Sonali ma'am.
Madam, you're very nicely you have presented. Very excellent. Okay, you know about the SI unit.
Sir, no.
No, don't. Okay, one kilometer, how many meter?
1000 meters, sir.
Very good, very good. Excellent. Okay, thank you. Thank you, thank you.
Okay. Achilles, just a very short question. It is 1 millimeter equal to decimeter.
1 millimeter, how many decimeter?
How many decimeter?
100 decimeters, sir.
Again, just you tried, but a little bit. 1
by
millimeter.
100.
Okay. Thank you. Thank you, Achilles. Nice project. Nice.
Next participant is Arna Mahanti. The code number is 238 and the fraction name, the project name is fractions. All the best, Arna.
Yes, ma'am. Oh, ma'am, can you hear? Ma'am, can you hear me? Hello, ma'am.
Yes, you are audible.
Yes, you are audible. You start now.
Mathematics is not about understanding different things and concepts. It is about getting used to them by applying the concept in everyday tasks. Good afternoon, everyone. Respected principal ma'am, my judges, teachers, and my dear friends. My name is Arna Mahanti. I am from class 3, section D. Today, I am going to show my project. My project name is fraction. A fraction represents a part of a whole, or more generally, any number of equal parts. Fraction is a word that is originated from Latin. In Latin, fractio means broken. A whole can be an object or a group of objects. If a number of things is divided into equal parts, each part will be a fraction of the whole. Example, 1 by 2, 1 by 4, 1 by 8, 1 by 12. It has two parts. The top part of the fraction is known as numerator and the bottom part is known as denominator. When an object is divided into two equal parts, then each part is called 1 half of the whole. Types of fraction. Like fraction. Fraction whose denominator are same are called like fractions. Example, 2 by 9, 3 by 9, and 4 by 9. Unlike fraction, fraction whose denominator are not same are called unlike fraction. Example, 3 by 5, 2 by 9, 5 by 6.
Proper fraction. Fraction whose numerator is smaller than its denominator. Example 3/10, 11/12. Improper fraction. Fraction whose numerator is greater than its denominator. For example, 5/2, 12/11. Mixed fraction. It is the combination of whole and fraction. For example, 2/1, 2. For example, this is one whole apple. I cut this apple in 2 pieces. See, I cutted these 2 equal pieces. Now, one piece is taken by my brother and one piece left with me. This is called 1/2. 1/2. Thank you. Have a nice day.
Very nice, Arna. Now it's over to judges.
Thank you, Arnab.
Yes, sir.
Your name is what, Arnab?
Arna.
Arna Mohan.
Arna. Okay, very nice. Nicely you have presented, Arna. And you know mixed number?
Yes, sir.
Okay. If 2 whole 1/3 is a mixed number or not?
Sir, what?
2 whole 1/3 is a mixed number?
Yes, sir.
If you will convert it into improper,
yes, sir.
What will come? Just you
Sir,
convert 7 by?
Sir, 3.
Very good, very good. Yes, you are right. Thank you.
Arna.
Yes, sir.
2/3 is which type of fraction? Proper or improper?
Sir, proper.
3/2?
Sir, improper.
Achha. 3/1?
Sir.
3/1?
Sir, it is not a fraction.
What is that?
Sir, a number.
Which type of number? Fraction you can say number. So it is which type of number?
Sir, improper.
Improper fraction. You are saying not fraction. Again, you are saying improper. Improper means it is improper fraction. You are saying that.
Yes, sir.
You are saying improper. Why? Because the numerator is 3 and denominator is 1. I told na. That's why.
Yes, sir.
Okay, but it is not a fraction. You are saying 3/1. You are saying it's not a fraction. It's a whole number. 3/1. We can also say a whole number or rational number. Anything you can say. Okay. Thank you. Thank you.
Thank you, sir.
Shubhampreet Satpathy, class 3, 239 and fraction foldable. Name of the project is fraction foldable. Shubhampreet Satpathy, code is 239. Name of the project is fraction foldable. He is absent. Now come to the next child. Ishan Ritik. Code is 240. Are you there, Ishan Ritik?
Yes, ma'am.
Ritik, yes, very good. 240. Name of the project is division made easy. Am I correct?
Yes, ma'am.
Okay, all the best. Start.
Yes, ma'am. Ma'am.
Yes.
Ma'am. Good morning, everyone. My name is Ritvik. My project is division made easy.
by an Ishan Ritwik Nayak, class 3, section F. Division. What is division? Division is splitting larger group into smaller groups. Each time I want to divide and equally share the things that I have, two dots and a line will help my mind to avoid mistakes. Division versus multiplication. Division is the opposite of multiplication, as division is repeated subtraction, whereas multiplication is repeated addition. Parts of division. Parts of division are as follows. Dividend, the number that will divide. Divisor, the number that does dividing. Quotient, the answer to division is quotient. Remainder, which remains after dividing into equal parts. Division machine. Division machine is the module or that make easy in understanding of dividing larger groups or object into smaller equal parts. So this is the project division machine. I am going to let us see how it works. So first we have to take a lucky card. Our lucky card is...
Turn off your virtual background, Ritvik. It is not visible. Virtual background,
Please come. This is division machine. Let us see how it works. This is dividend machine. This is dividend. My machine has 3 columns. This dividend, quotient, and divisor. So the dividend is 2. There are divisor 9. So first we have to take a lucky card. Our lucky card is 6 divided by 2. So let us keep it here. So, as our dividend is 6, in dividend column we should put 6 ticks. 1, 2, 3, 4,
6 by 2 करिए दिखावा
5
तो छोटा
and 6
by 2 करवा देना.
So as our divisor is 2, 1 glass in divisor column 1 glass contains 2 sticks. 1, 2, 1, 2, 1, 2. So divisor we have kept, it contains 2 sticks, 3 glasses. So our quotient is 3. अगला को छोड़ो.
सर्वांनी चाहिए स्टिक में.
Quotient. Our quotient is 3. There are no sticks remain. So our remainder is 0. Thank you. Have a nice day ahead.
Now it is over to judges.
Madam, this is code number 239. Madam, excuse me.
240, sir. 240. 239 is absent. 239 is absent.
No, ma'am. 239 is present.
Present, but he is not answering.
Ma'am, I am code number 239. Shubham is Satpati.
Okay, Subham, you listen. You don't worry. Listen.
Okay.
Subham,
Okay,
have patience. Have patience. When we call your name, that time you did not responded. So we call to the next child. Don't worry. Now it's your turn. Yes. Okay. Okay. Are you present? Okay. What's your name? Just you have not renamed accordingly, I think. Yes, Subhampreet Satpathy. But when you have renamed, your name is not showing. That is the reason we thought that you are absent when we are searching your name. What name you have given? Just you tell your spelling better.
Ma'am,
you have written Smruti Rekha Satpathy. We can see you. You rename yourself. You have written Smruti Rekha Satpathy.
Ma'am, it is my mother's name.
You rename. That is the reason we thought that you are absent.
No, ma'am, I disconnect.
Now you get ready. After the questionnaire round of Ritvik, your turn will come. Get ready. So now it's over to judges. If there is any question to ask, now judges can ask the question to Ritvik.
Thank you, Ritvik. Ritvik, you are hearing me?
Yes, sir.
Very nicely you have presented, beta.
Thank you, sir.
Okay, can you tell me what is the relation between the dividend, divisor, remainder, and quotient?
Ma'am, sir.
Ritik.
Sir, dividend is which divide.
Dividend equals to?
Dividend equal.
Yes. Divisor into quotient plus remainder.
Divisor is which will be divided.
Yes. Dividend equals to divisor into quotient plus remainder. Okay?
Sir. Okay, sir.
Yes. Okay. Thank you.
Okay.
Ritvik, first you stop share. Whatever you share, just to stop it. Ritvik.
Sir.
Okay. Achha, suppose I'll tell you to divide a number by 7. Are you listening me?
No, sir.
Suppose I'll tell you to divide a number by 7.
Yes, sir.
Then can the remainder be 9? I'll say number by 9. Is it possible? Suppose
No,
I'll say why not possible?
Ma'am, so because
yes.
it is bigger number than 7.
What is that 7 called? 7 is the?
7 is the divisor.
Okay. Means your remainder should not be greater than the divisor. You are saying this?
Yes, sir.
Okay. Thank you. Next.
Next participant is Subhampreet Satpathy, and the code number is 239, fraction foldable. Are you ready, Subham?
Yes, ma'am.
Okay, all the best.
Thank you, ma'am. A very good afternoon to one and all present here. I am Subhampreet Satpathy from Class 3E, standing before you in this virtual platform to present my project on fraction foldable. First, let us understand what is fraction. Fraction is a part of a whole. That means when a whole is divided into equal parts, each part is called fraction of the whole. Now, coming to my project, fraction foldable. This is fraction foldable. This is one whole. It is represented as 1. Here, a whole is divided into 2 equal parts. Each part is called 1/2 of the whole. 2 halves make a whole. Here, a
a whole is divided into 3 equal parts. Each part is called 1/3 of the whole. 3 1/3s make a whole. Here, a whole is divided into 4 equal parts. Each part is called 1/4 or quarter of the whole. 4 quarters make a whole and 2 quarters make 1/2. Here, a whole is divided into 5 equal parts. Each part is called 1/5 of the whole. 5 1/5 make a whole. Like this, you can do 1/6 means 1/6 of the whole. 1/8 means 1/8 of the whole. 1/9 and 1/10. Now I am going to show you how fraction is used in creativity. This is a fraction fish. I have used half of the whole for its body, 1/4 and 1/8 of the whole for its mouth, and for the fins I have used 1/8 of the whole, and for the tail of fishes I have used 1/4 of the whole. Like this, I have a fraction flower by using 1/2 and 1/4 of the whole. Like this, you can do many creativity using fractions. With this, I end my project. Thank you. Have a wonderful day ahead.
Okay, thank you. So it's over to judges now.
Thank you, Shubham. Nicely you have explained, and your paper cutting method is very nice. Nicely you have prepared also. Shubham?
Thank you, sir. Yes, sir.
Okay, suppose you divide a cake into 5 equal parts, right?
Yes, sir.
Divide a cake into 5 equal parts. Suppose
yes,
2 parts you have taken. 2 parts you have eaten.
Yes.
Okay. Sir. How you will represent in a fraction?
Sir.
How you will represent in a fraction?
Sir, if I cut cake into 5 equal parts and I have taken 2 equal parts, then I have left 3 equal parts.
How you will write in the fraction?
First, I will write 1/5 minus. First, I will write 5.
Listen, you have cut your cake and divided into 5 equal parts. 2 parts you eaten, right? Yes. How you will write in the fraction? In fraction, how you will write?
2/5 I have taken.
Yes, very good, very good. That I want to know. 2/5 is the right answer. Okay, thank you.
Welcome, sir.
Yes. Okay, Subhamjit. The same thing I am asking. Suppose that the cake is divided into 6 equal parts. So what is each part called? Each part is the which fraction? By which fraction? Each part is 1/6.
1/6.
Achha, how many? Okay, very good. How many 1/6 are necessary to make the half of that cake?
3 1/6.
How many ones? Okay, good. Thank you.
Welcome, sir.
Thank you. Next, is Janmesh Das. The code number is 241 and the project name is Earth Metron City. Janmesh, are you ready?
Yes, ma'am.
Okay, all the best.
Thank you, ma'am. Good afternoon, respected principal ma'am, honorable judges, respected teachers, my dear friends, and all present over here. I am Janmesh Das of class 4 going to explain about my project. This is the map of my project city. The name of my project city is Earth Metron City. This city is mainly based on geometry, which is an ancient branch of mathematics. The aim of this project is to learn different types of lines and angles, and by using the same, we made roads, buildings, and other structures safely. In my city, I have made the roads using lines. Lines can extend in both sides, in both directions infinitely. It can be horizontal, vertical, and diagonal. I have made the roads of my city using parallel lines. Parallel line means the lines which are next to each other. Can be top or bottom or side by side, but those lines will never intersect. The examples of parallel lines are the edges of the scale and the edges of the smart board which we use in our classroom. I have made this road using perpendicular lines. Perpendicular line means the lines which connect with each other and form a 90-degree angle. In our daily life, we see roads made up of perpendicular lines at the traffic posts for the smooth movements of traffic. Here, some roads intersect with each other and create some space. Do you know what this space is called? This space is called as an angle. We measure angles in degrees. We draw and measure angles using a protractor. Here, this road near where the school, the apartment, bank, and the park are situated, the road form a right angle. This is a right angle. Here the also form an angle, but this angle is less than the right angle. This angle is known as the acute angle. The measurement of acute angle is more than 0 degree and less than 90 degree. This is a acute angle. Here the roads near the police station and the fire station form an angle, and this angle is more than right angle. This angle is known as obtuse angle. The measurement of obtuse angle is more than 90 degree and less than 180 degree. This is a obtuse angle. This is a obtuse angle. Here the roads form an straight angle. It is also known as a flat angle. Measurement of straight angle is 180 degrees, exactly 180 degree. This is the straight angle. Here in the clock of the school, the time is 3:40 and the hands of the clock form an reflex angle. The measurement of reflex angle is more than 180 degree and less than 360 degree. This is a reflex angle. When the hands of the clock are at the same position, are at the same number, they form a full rotation, or it is also known as full angle. The measurement of full angle is 0 degree. When the example of full angle are when the hands of the clock are at the time of 3:15, 4:20, 6:30, 9:45, they form the roof of the fire station is made up of a triangle. It has 3 angles and they are acute angles. In my city, all the buildings are made using right angle. Here, the roof of the school is made of obtuse angle. I hope this project gives a clear idea about lines and angles. From this, we know that mathematics expresses itself in almost every facet of life, in nature all around us, and in technology in our hands. Using technology and technological tools, it is easy to learn mathematics more deeply. Thank you.
Very
Okay, thank you,
excellent.
Janmesh. Yes, sir. Yes, sir. You continue.
Janmesh,
Thank you, sir.
you have shown that each and every step of our life, we are facing the mathematics. Yes?
Yes, sir.
A very small question for you. How many arms we need to make an angle?
Sir, 2 arms.
2 arms. Very good.
Sir, the diagonal arm is known as the terminal arm, and the horizontal arm is known as the initial arm.
Okay. If the angle will be 89.5 degree, what type of angle is this?
Sir, it is an acute angle.
Very good, very good. Excellent. Keep it up. Very nicely you have presented. Thank you, sir. You.
Okay. Janmesh.
Yes, sir.
Okay, why you kept the name Earth Matron City? Why your project name is Earth Matron City? Tell me.
Sir, the geometry is divided into 2 words, Earth and Metron. So I have named it as Earth Matron City.
Okay, that means you want to say here that it is geometry.
Yes, sir.
Okay. Achha, what you told what is full angle? What is the measure of full angle you told? Just.
Sir, 0 degree.
Is it full angle? Full means what do you want to say? What is full? Sir, what is the spelling of full? Who you are saying it's?
Sir, FULL.
Okay, if it's full means the angle are already filled. So what is that angle?
Sir, full angle.
Means 0 degree, nothing. You are saying full, but nothing is there. 0 degree means no degree. We generally in mathematics what is 0 means nothing.
Sir, it makes a full circle and it is measurement is 0 degree.
Okay, beta. Thank you. You tried a lot. Thank you. Nice presentation.
Thank you, sir.
Now next child is Vishwabhushan Patra. Code is 242. Area of a circle. Vishwabhushan Patra.
Vishwabhushan
is absent, I think. Vishwabhushan is absent. Next child is Sampriti Nayak. Code is 243. Sampriti Nayak. Code is 243. She is also absent.
I request the judges to mark it as absent.
Yes, ma'am.
Yes, sir.
So serial number 13 and 14 both are absent. Now 15. Ashwin Swai. Code number 244. Angle and its properties. Ashwin Swai.
Yes, ma'am.
Okay, all the best. Start.
Thank you, ma'am. Ma'am, can I share my screen?
Yes.
Thank you, ma'am. Revered judges, respected teachers, and my dear friends, I am Ashwin Swai from Class 4, Section E. Today, I am going to speak about the topic triangle and its properties. The term triangle has two words in it. Tri, which means three, and angle, which means the corners of a shape. On the basis of length, they are classified into scalene triangle, isosceles triangle, and the equilateral triangle. On the basis of angle, they are classified into acute angled triangle, right angled triangle, and the obtuse angled triangle. There are many properties of triangles: exterior angle property, angle sum property, congruence property, and the Pythagoras theorem. But I would like to elaborate on the Pythagoras theorem. Pythagoras observed that in a right angle triangle, the square of the hypotenuse. Yes, ma'am.
So, where is your slides? You click on the slides.
Ma'am, I am showing you the slides.
Which one?
Pythagoras theorem one.
But it is not showing now. You click on that.
Ma'am, can I share again the slides as I think.
No, it is there. It is there. Only click on that particular one. Okay.
Can I share the slide?
Yes,
again?
yes.
Ma'am, now can you see?
Double click. I can. If you cannot see it properly, it is very small. Somebody should be there to help you. Double click on that slide.
Actually, ma'am, I am doing the slide share, and if I double click, it would take me to the next slide. Ma'am, shall I proceed?
Yes, proceed. Proceed.
Pythagoras observed that in a right angled triangle, the square of the hypotenuse is equal to the square of the other two sides combined. So here I have a right angled triangle with sides A, B, and hypotenuse C. I have made squares beside all the sides of this right angled triangle. Let's have a look. The squares A and B are filled with mustard seeds. Now let's rotate this. See, all the mustard seeds from the squares A and B now completely fill the square C. This proves our Pythagoras theorem. Now I am showing you a placard. Here I have drawn a right angle triangle and I have drawn squares beside each of the sides. Now I am going to paste this colorful paper on the B square. Now I am taking green colored paper for the A square. According to the Pythagoras theorem, A squared plus B squared equals to C squared. So let's now prove this theorem. Now I'm going to paste this B square here in the larger hypotenuse square. See, this activity again proves the Pythagoras theorem. Therefore, to conclude, A squared plus B squared equals to C squared. Thank you and have a wonderful day ahead.
Thank you, Ashwini.
Thank you, sir.
Thank you. Very nicely you have presented your standard 4 student, I think.
Thank you, sir.
Now a very small one, you are explaining the Pythagoras theorem. It is a great job for you also. Okay. And a small question.
Yes, sir.
Pythagoras theorem, can it be applicable in an isosceles triangle?
No, no, sir. Because Pythagoras theorem is only applicated. It can be only useful in a right-angled triangle.
Yes, very good. You know the Pythagorean triplet?
Yes, sir. Sir, Pythagorean triplets are the sets of numbers which satisfy the Pythagorean equation or this Pythagoras theorem.
Okay. Can you give one example of an Pythagorean triplet?
Yes, sir. One of the basic example is 3, 4, 5, and to add more, 7, 24, 25, and 14, 48, 50.
Okay. That means 3 square plus 4 square equals to 5 square, right?
Yes, sir.
Achha. If I will divide by 100 in both the sides, it will come in the decimal number. Suppose 3 square by 100 plus 4 square by 100 is equals to 5 square by 100.
Yes,
it is also satisfying the a square plus b square equals to c square.
Yes, sir.
Can it be 0.3 plus 0.4? 0.3 square plus 0.4 square is equal to 0.5 square?
Yes, sir.
Are these your Pythagorean triplet?
Yes, sir.
0.3, 0.4, 0.5, these are also Pythagorean triplets?
Yes, sir.
No, better.
Sorry, sir. Actually, sir, I don't know much about these Pythagorean triangles.
Thank you. You tried a lot. Thank you so much.
Thank you, sir.
Because Pythagorean triplet is restricted for positive integer, right?
Yes, sir.
Or natural number. Only for the natural numbers.
Sir, it is restricted for natural numbers like or decimal numbers.
Yes. Very good. Thank you so much.
Sir, can I tell you the formula of the how to find the triplets?
Triplet?
Yes.
Yes.
Sir, it is 2m plus 2m squared plus m squared minus 1 squared equals to m squared plus 1 squared.
Yes, 2m, m squared plus 1, m squared minus 1.
Thank you,
okay?
Sir. Yes,
sir. Thank you so much.
Thank you, sir.
Thank you.
Ashwin.
Yes, sir.
So you are interacting with the sir very well, but I want to know, just you told a square plus b square equal to c square. What are these a, b, c?
Sir, scientists use this ABC to simplify it further. And do you know, sir, many mathematicians prefer to tell this a squared plus b squared equals to c squared as perpendicular squared plus base squared is equal to hypotenuse squared.
This thing I'm asking, what is that? So ABC are the, so finally ABC are the?
Sir, A is the perpendicular, B is the base, and C is the hypotenuse.
Okay. Means you are saying side of the, what is right angle triangle, isn't it? Okay. Thank you.
Thank you, sir.
Next child is 16, serial number 16, Moyan Jenna. 245. Code is 245. Moyan Jenna. Now he is absent. Moyan Jenna. 245 absent. Now Riyans Mahapatra. Yes, code number 246. All the best, Riyans.
Good evening, everybody. My name is Riyans Mahapatra from class 4. I am standing for you to tell application of Vedic math to find out square of numbers. You are wondering what is Vedic math? Vedic math is the technique or trick of math that makes math easier to do. Square. The number multiplied itself twice is called the square of the number. We are going to rule number 1. The number ending with digit 5. We'll take an example of it. We'll take square of 45. We'll take the first digit and multiply it with its successor slash square of 5 is equal to 20 slash 25 is equal to 2025. 2025 is the answer. We'll take another example, square of 105. We'll take the first digit and multiply it with its successor slash square of 5 is equal to 110 slash 25 is equal to 11025. 11,025 is the answer. We'll go to rule number 2, taking 100 as the working base. We'll take an example of it, square of 87. 87 is 13 less than 100. So less 87 less 13 slash square of 13. It is 74 slash 169. 100 has 2 zeros and here are 3 digits. So we'll add 1 to 4 is equal to 7569. 7569 is the answer. We'll take another example of square of 114. 114 is 14 more than 100. So we'll add 14 slash square of 14 is equal to 128 slash 196. And the 100 has 2 zeros and here are 3 digits. So we'll add 1 to 8 is equal to 12996. 12,996 is the answer. We will go to rule number 3, taking 1000 as the working base. We'll take an example of it. We'll take square of 984. 984 is 16 less than 1000. So we'll less 16 slash square of 16 is equal to 968 slash 256. 968,256. 9,68,256 is the answer.
Madam, it is not visible anything.
Here it is visible, sir. Everything is visible. I think.
Another sir, you pin it, that boy, then you can see.
That boy name, sir?
Pin that boy.
Yes, now it is visible.
Yes.
And I will restart from starting.
No.
Okay, sir. We will take another example of square of 1006. 1006 is 6 more than 1000. So we'll add 6 slash square of 6 is equal to 1012 slash 36. 1012. 1000 has 3 digits and here are only 2 digits. So we'll add 10 to it and write 36. 1012036 is the answer. We'll go to rule number 4, taking multiples of 10 as the working base. We'll do an example of it. We'll do square of 67. The nearest multiple of 10 multiple of 67 is 70. So we'll take 70 as the base. 67 is 3 less than 70. So we'll less 3 slash square of 3 is equal to 64 into 7 slash 9 is equal to 7 into 4 is equal to 28 and 6 42 44 9. 4,489 is the answer. Now we'll take another example of square of 81. 81, the nearest multiple of 10 multiple of 81 is 80. So 81 is 1 more than 80. So we'll add 1 slash square of 1 is equal to 82 into 8 slash 1 is equal to 16, 64, 65, 656, 1. 6561 is the answer. Thank you. Have a nice day ahead.
Thank you very much, Rians. Now it is over to judges.
Thank you, Priyans.
Yes, sir.
Very nicely you have explained the Vedic mathematics.
Thank you, sir.
And okay, by your this rule,
sir, what?
You show it the product of by this rule number 4. You see, okay?
Yes, sir.
By rule number 4, you multiply 21 into 21.
Sir, what you told?
21 square.
Okay.
21 square you find out?
Square of 21.
Yes.
The nearest 10 multiple of 21 is 20. So we'll take 21, and 21 is one more than 20. So we'll add 1 slash square of 1 is equal to 22 into 2 slash 1 is equal to 4 and 1. 441 is the answer, sir.
Yes, very good. Another simplest method is there to find the 21 square. Okay, how you will find? Here you see 21 unit per digit is what?
1, sir.
1. You write 1, 1 ja 1.
Sir, 1 into 1 is equal to 1.
1 square is 1?
Yes, sir.
Okay, write 1.
Yes, sir.
Then you multiply all the digits. Here 2, 1 and power 2 is there.
Yes, sir.
You multiply 2 into 1 into 2. You multiply 2 into 1 into 2 because 21 is there. 2 into 1 into 2, power 2 is there.
Yes, sir. 2 into 1 is equal to 2 and 2 into 2 is equal to 4.
Right, 4. Yes, 4 you write. Then what is the tens place digit?
Tens place digit is 2, sir.
So 2 square you write?
Sir, 4.
So 441 is coming now?
Yes, sir.
It is a very simplest trick to find the square of any numbers. Okay?
Yes, sir.
Okay, very good. Very nice. Thank you.
Okay, Rayans.
Yes, sir.
Can you tell me two numbers whose square is the number itself? Just you found a lot of square of so many large number. Just I am also not able to find so easily and so quickly what you did. But my question is, what is it? Tell me a number. Tell me two numbers whose square is the number itself.
Sir, 1.
Anyone? Any more?
Any more? Where is Sir, 0.
0. You should know this. Just you told just by listening from others. Someone is saying, okay, very good. Very good. Okay, thank you. And also -1 square is 1, but that you don't know. But you are which class you are?
Sir, 4.
4 now. Okay, you don't know about the year. Okay. Integers. Thank you. Proceed.
Okay, thank you very much, Rians. Next child is Shreyans Sahu and code is 247. And name of the Shreyas, are you there?
Yes.
247.
Yes,
and your topic is fractions.
Yes, ma'am. Ma'am, can I say?
Yes, start.
Good afternoon, everyone present over here.
Welcome to our exhibition, AllyTech 2022. I am Shreyas South from class 4A, going to present on my chosen topic, fraction. What is fraction? A fraction represents a numerical value which defines the part of a whole. A fraction always means numerator is divided by denominator. For example, A by B. Here, the upper part A is known as numerator and the lower part B is known as denominator. It is denoted by using the symbol hyphen or forward slash and read as out of or divided by. The denominator of a fraction tells us the total number of parts into which the figure is divided. The numerator tells us the parts that are chosen. For example, this is the big one represents one whole. Now the yellow one represents 1 byte and the pink one represents 7 bytes. Now the yellow one represents 2 bytes and the pink one represents 6 bytes. Now the yellow one represents 3 bytes and the pink one represents 5 bytes. Now the yellow one represents 4 bytes and the pink one also represents 4 bytes. So it is equivalent to 1 by 2. Here the yellow one represents 5 bytes and the pink one represents 3 bytes. Now the yellow one represents 6 bytes and the pink one represents 2 bytes and the pink one represents 2 bytes. And so on. Types of fraction. There are different types of fraction. Proper fraction. The fraction in which the numerator are smaller than denominator are called proper fraction. For example, 8 by 9. Improper fraction. The fraction in which the numerator are greater than denominator are called improper fraction. For example, 9 by 8. Like fraction. The fraction in which the denominators are same are called like fraction. For example, 7 by 11 and 13 by 11. Unlike fraction. The fraction in which the denominators are different are called unlike fraction. For example, 4 by 7 and 13 by 16. Unit fraction. The fraction in which the numerator are at 1 are called unit fraction. For example, 1 by 9 and 1 by 13. Equivalent fraction. The fraction which express same part of the whole but have different names are called equivalent fraction. For example, 1 by 2 and 2 by 4. Mixed fraction. It is a combination of a whole number and a proper fraction. For example, 1 whole 2 by 7 and 6 whole 1 by 8. The uses of fraction. The fraction are used in our daily life. They are mostly used in cooking, time, pharmacy, and measuring length. The most common everyday fraction is pizza. This is a pizza. It is divided into 8 equal parts. Now, I will take 1 part from it. So, it will be 1 by 8. I will take 2 parts from it. So, it will be 2 by 8. And so on. 3 by 8, 4 by 8, and like this. The fraction in cooking are, we generally use 1 by 2 cup of sugar or 1 by 4 teaspoon of salt or cinnamon. The fraction of apple and the fraction of orange is also an example of fraction of cooking. The fraction is used in telling time. Each minute is a fraction of hour. This is a real example of fraction in time. This is 1 by 2. The fraction is used in pharmacy. The drug concentration are expressed as fraction. The fraction is used in measuring length. For example, 5 whole 8 by 13 inches. So, in this project, we conclude the fraction as part and parcel of our daily life. Thank you and have a nice day ahead.
Thank you, Shreyas. Now it is over to judges.
Thank you, Shreyas.
Thank you,
Very nice project and nicely you have explained also. Who has helped you to make this project? Many things you have prepared.
Ma'am, the chart is drawn by me, but the margin sellotape is drawn by my mother.
Okay, very nice.
And this project is done by me and my mother.
Very good, very good. Okay, so 1 by 2 is what type of fraction?
Sir, the 1 by 2 is the equivalent fraction.
Yeah, 1 by 2 is an equivalent fraction.
And the 1 by 2 is the equivalent fraction and the proper fraction also.
Okay. 1 by 2 is equivalent to which fraction?
Sir, 1 by 2 is equivalent to 2 by 4. 4.
Yeah.
2 by 4 and 4 by 8.
If I will write a minus 1 by 2, will it be a fraction?
No, sir.
Yes, very good. Fraction can never be negative. Okay? Thank you.
Thank you, sir.
Thank you. Thank you, Shreyas.
Shreyas,
Yes, sir.
very good presentation it was. But suppose you are showing one pizza, na?
Yes, sir.
Yes. I like that pizza very much. Suppose what happened? 2 pizzas, like that 2 pizzas you have. Suppose you have 2 pizzas. Your mother has prepared 2 pizzas. One is for you, and suppose one is for your friend. One friend came to your home, and 2 pizzas are prepared by your mother. And it is divided into how many parts? You tell me there. It is divided into how many parts? You see your pizza. 8 parts. Okay, it is divided into 8 parts. So what happened? So you that item 1 is divided into 8 parts, and you take 4 parts, isn't it? But your friend, what he did, he divided into 16 part. You divided into 8 part, na? But he divided into 16 parts, and you took from your pizza, you took 4 parts out of that 8 parts, but your friend took 8 parts from 16 parts. So whose share is more?
Sir, it is 10.
Very good. Thank you. Proceed.
Thank you, sir.
Thank you, Shreyas. Now next child is Swayam Siddhi Biswar. And
Yes, ma'am.
code number is 248. Your topic name is math skill.
Yes, ma'am.
Okay, all the best.
Good evening, everyone. I am Swayam Siddhi from class 4 and my topic is technology in maths. In maths, we use technology to solve virtual models of mathematics like arithmetics, virtual
Switch on video. Swayam Siddhi, switch on video.
Ma'am, I have switched on my video.
But we cannot see you. Switch on your video. It is off.
Yes, madam. It is.
Yes.
Good evening, everyone. I am Swayam Siddhi from class 4 and my topic is technology in maths. In maths, we use technology to solve virtual models of mathematics like arithmetics virtual library to create graphs more easily by Microsoft Excel and to practice math skill on the website like A+. We use a calculator to solve addition, subtraction, multiplication and division. Let me show you in my computer. This is my computer. And let me show you the Microsoft Excel first. This is Microsoft Excel. These small boxes are called cells. We can add, subtract, multiply, and divide here. We add here and so it's compulsory to type equal to Then we will type the number and enter. Answer is 857. If we will click the same, here is the formula bar and here is the formula. In the same way, we can do the subtraction. Now, I am going to show you my practice online test. This is a link of practice online test. Now let me multiply and tell you something.
Hello, Swam Siddhi, any problem? Continue.
Ma'am, my net is unstable. Ma'am, it is coming.
Yes.
So
Yes.
here 17 multiplied by 18. So the answer is 306. Yes, this answer is correct. Then 20. That is written 20 multiplied by 15. So the answer is 302. Oh no, this answer is wrong. I can multiply it again. So the correct answer is 300. So this way we can check our answer. Thank you. Have a great day ahead.
Now, sir, please.
Thank you, Swam Siddhi.
Welcome, sir.
Thank you. Can you give any two application in your day-to-day life? In what way you are using this application? First thing, so in your teaching learning process you are using. Yes or no? It is a simplest way.
Sir.
It is a simplest way to calculate addition, subtraction, multiplication, division. Yes or no?
Yes, sir. It is the easiest way.
Yes. Any other application can you give? Where you are using this? Okay. Okay,
Sir,
thank you.
Sir, I can tell. Sir,
Yes.
we use Microsoft Excel in offices and shops.
Yes. Now, though, every shop they are using also many applications. This type of applications, how they can shortcut way or easily they can calculate their
Yes,
items,
sir.
what they are selling. Yes or no?
Yes, sir.
Yes. If you will go a big malls, they are calculating very few minutes they are taking to calculate how many items you are purchasing, how much time they are taking to calculate. Okay, this type of applications they are using there. Fine?
Yes, sir.
Okay, thank you.
Yes, sir. Welcome, sir.
Okay, Swam Siddhi. It was you presented it nicely, and you are what is no question to ask, only thing to say. Less mathematics and more computer expert. Okay, thank you, thank you.
Thank you, sir.
अच्छा, ठीक है. Now, next child is Akanksha Acharya. Code is 249 and name of the topic is types of triangles. Akanksha Acharya, code is 249 and your topic is types of triangles. All the best.
Thank you, ma'am. Ma'am, am I audible?
Yes, yes, clearly audible.
Good evening to one and all present over here.
This is Akanksha Acharya from Class 5, Section C. Today, I am here to represent my project before you on the topic Types of Triangles. As we all know, mathematics is not about understanding different concepts. It is about getting used to them and applying them in our everyday tasks. Mathematics is in and around us in the form of numbers, shapes, sizes, volume, etc. Our task is to figure out and identify these numerous situations and things around us. Triangle is a polygon with 3 sides and 3 vertices. It is a basic geometrical shape. Here, in my project, Types of Triangles, I have developed a model in which I will explain the various kinds of triangles. According to the length of the sides, triangles are classified into 3 types. They are scalene triangle, isosceles triangle, and equilateral triangle. With respect to their interior angles, triangles are classified into 3 types. They are right triangle, acute triangle, and obtuse triangle. This is a picture of equilateral triangle. In an equilateral triangle, all the side lengths are of equal measure. In an equilateral triangle, the interior angles measure 60 degrees. Since the angles are same in an equilateral triangle, it is also known as equangular triangle. This is a picture of isosceles triangle. In an isosceles triangle, the 2 of the 3 sides are equal. In other words, we can say in an isosceles triangle, there are 2 equal sides and 2 equal angles. This is a picture of scalene triangle. In a scalene triangle, all the side lengths are of different measures. In a scalene triangle, the interior angles are also of different measures. This is a picture of acute angle triangle. In an acute angle triangle, all the 3 angles are less than 90 degrees. Here, you can see the angles are less than 90 degrees. This is 85 degrees, this is 60 degrees, and this is 35 degrees. This is a picture of right angle triangle. In a right angle triangle, one angle is equal to 90 degrees. This is a picture of obtuse angle triangle. In an obtuse angle triangle, one angle is greater than 90 degrees. Thank you. Have a nice day ahead.
No, sir, please. Thank you,
Akanksha.
Welcome, sir.
You have nicely presented. Very nice.
Thank you, sir.
Okay, that means you have explained the types of triangles.
Yes,
on the basis of sides, basis of angles. Okay, my small question. How many maximum acute angles can have a triangle?
Sir, there are 3 acute angle triangles.
Okay. Thank you. And you know the right angle triangle?
Yes, sir.
What is right angle triangle?
Sir, in a right angle triangle, one angle is equal to 90 degrees.
Yes. How many right angles? How many right angles can a triangle have?
Sir, 1.
Only 1.
And the other are acute.
Yes. If one will be 90 degree right angle, other 2 will be acute.
Acute, sir.
Okay. Is it possible to be a 2 obtuse angle in a triangle?
No, sir. It will be not possible because if there will be 2 obtuse angle in the right angle triangle, so it will exceed 180 degree. And if it will exceed 180 degree, then we cannot construct a triangle.
That means one obtuse angle is possible in a triangle. Okay?
Yes.
Yes. Good. Thank you.
Okay, Akansha. Very good representation it was, but one very short question is there.
Yes.
Then, can a right angle triangle be isosceles?
Sir, a right angle triangle can be an isosceles.
Can a isosceles triangle be equilateral?
No, sir. It cannot be equilateral because equilateral triangle has 3 equal sides, but isosceles triangle has only 2 equal sides.
Okay, okay. In right angle triangle, three sides cannot be made equal.
Can you please again repeat the question, sir?
Can we make a right angle triangle with all the 3 sides equal?
No, sir. We cannot make.
Okay, okay. Thank you. Proceeds.
Okay, thank you. Now next child is Tanmay Kumar Sahu, and code is 250. Topic is how to find LCM and SCF easily.
Yes, ma'am.
Yes, all the best, Tanmay.
Thank you, ma'am. Good evening, one and all present over here. Myself, Tanmay Kumar Sahu from class 5C, standing before you on this virtual platform to present my model, which is based on the topic how to find LCM and HCF easily. Today, I will show HCF working model and LCM working model. For that, I have arranged 30 cups in 3 rows. Each cup represents a number, starting from number 1 and ends at number 30. First, we will find LCM. For that, we have to take an example. Let's take an example of 3, 4, and 6. To find the LCM of 3, 4, and 6, we have to first find the multiples of 3, 4, and 6, or we can also say that we have to recite the tables of 3, 4, and 6. First, I will recite the table of 3. 3 ones are 3, so I will put 1 pebble in cup number 3. 3 twos are 6, so I will put a pebble in cup number 6. 3 threes are 9. 3 fours are 12. 3 fives are 15. 3 sixes are 18. 3 sevens are 21. 3 eights are 24. 3 nines are 27. And 3 eights are 30. Now we have find all the multiples of 3. Now we will find the multiples of 4. 4 ones are 4. 4 twos are 8. 4 threes are 12. 4 fours are 16. 4 fives are 20. 4 sixes are 24. 4 sevens are 28. Now we have also find the multiples of 4. Now we will find the multiples of 6. 6 ones are 6. 6 twos are 12. 6 threes are 18. 6 fours are 24. 6 fives are 30. Now we have find all the multiples of 3, 4, and 6. Now we will find the common multiples of 3, 4, and 6. For that, we have to look in cups that have 3 pebbles. Cup number 12 has 3 pebbles. And cup number 24 has 3 pebbles. So we get 12 and 24 as our common multiples of 3, 4, and 6. As we know that LCM means least common multiple. So 12 is the least common multiple of 3, 4, and 6. So we get 12 as our LCM of 3, 4, and 6. Before I proceed to HCF, first I will like to take all the pebbles out of the cups. Now I have taken out all the pebbles from all cups. Now we will proceed to HCF. For that we have to take an example. Let's take an example of 12 and 24. So for
to find HCF of 12 and 24, we have to first find the factors of 12 and 24. So first I will find the factors of 12. 12 ones are 12. So I will put 2 pebbles in both cup number 1 and cup number 12. 6 twos are 12. So I will put 2 pebbles in both cup number 2 and cup number 6. 3 fours are 12. So I will put 2 pebbles in both cup number 3 and 4. So now we have find all the factors of 12. Now we will find the factors of 24. 24 ones are 24. So I will put 2 pebbles in both cup number 1 and cup number 24. 12 twos are 24. So I will put 2 pebbles in both cup number 2 and cup number 12. 3 eights are 24. So I will put 2 pebbles in both cup number 3 and 8. 4 6 are 24. So I will put 2 pebbles in both cup number 4 and cup number 6. Now we have find all the factors of both 12 and 24. Now let's find the common factors of 12 and 24. For that we have to look in cups that have 2 pebbles. Cup number 1 has 2 pebbles. Cup number 2 has 2 pebbles. Cup number 3 has 2 pebbles. Cup number 4 has 2 pebbles. Cup number 6 has 2 pebbles. And at the last, cup number 12 has 2 pebbles. So we get 1, 2, 3, 4, 6 and 12 as our common factors of 12 and 24. As we know that HCF means highest common factor. So 12 is the highest among all. So we get 12 as our HCF of both 12 and 24. In this way, we can find LCM and HCF easily through this model. Thank you for listening to me.
Thank you, Tanmay. Now,
Yes,
sir,
sir.
please.
Thank you, Tanmay. Very nicely you have explained and very shortcut way how to find the LCM and HCF. You
Yes,
have
sir.
explained very nicely. Can you tell me what is the full form of LCM?
Sir, the full form of LCM is least common multiple.
Least common multiple. Okay. What is the HCF between two consecutive numbers?
Sir, the HCF of two consecutive numbers is 1.
Yes. If you will find their LCM.
Sir, their LCM is their product itself.
Good. Very good. Yes. Thank you.
Welcome, sir.
Tanmay, how many cups you have used there?
Sir, 30 cups.
30 cups. Can you find the LCM of 31 and 62 or 29 and 87 using this cup?
Sir?
Can you find LCM of 29 and 87?
Sir,
Using
29 and 87.
you will using your cups.
Okay, sir. Sir, 87 is more.
More means what more you are
Sir,
saying?
I have arranged 30 cups.
Oh, acha, means you can find up to very small numbers. Okay, okay. For large numbers, we have to take so much cups there so that the room will be filled with cups, isn't it?
Yes, sir.
Isn't it? Okay, okay. Thank you.
Thank you, Tanmay. Next child is Ashreya Parida and code is 251. Topic is circle the special one. Ashreya Parida, are you there?
Yes, ma'am.
Okay,
Ma'am,
all
am I
the best.
audible?
Yes, yes.
Yes, ma'am. Good evening, everyone. I am Ashriya Parida from class 5E. Today, I am going to speak on the topic circle, the special one. A circle is a two-dimensional figure formed by a set of points that are at a constant or a fixed distance. The circle is only the boundary and the whole figure is called a disk. Terms related to circle. Circumference. The boundary or the very special name of perimeter of circle is called circumference. Its formula is 2 pi r. Radius. The line that is drawn from the center of the circle to a point at any point of the circumference is called the radius. The straight line that joins any 2 points on the circumference is called the Ma'am, am I audible?
Yes, yes, continue.
I got disconnected. Yes, ma'am. It is called the radius. The straight line that joins any 2 points on the circumference is called the chord. Diameter. The line that passes through the center of the circle and touches any 2 points on the circumference is called the diameter. It is the longest chord of the circle. Arc. Arc is the part of the circumference in which the largest arc is called, here it is called major arc and the smaller one is called minor arc. Sector. It is a slice of a circle just like a pizza which is bounded by 2 radius and the included arc of a circle. Area of a circle. To find the area of a circle, we need to use the formula pi r square. It is a very important concept of circle. It is denoted by the symbol pi. Its approximate value is 3.142857 or 22 by 7. Now I am going to prove my theorem. So I am going to prove the theorem that is equal chords of circles subtend equal angles at the center. So we are given that AB here, AB and PQ, they are equal chords of circle with a center O. So triangles AOB and triangle POQ are equal to each other. So chord AB and PQ, in that we have OA and OP, they are equal. OB and OQ, they are the radius of the circle which are equal. Triangle AOB and triangle POQ, they are congruent to each other according to the side congruence in which the sides of a triangle are equal to each other. Angle AOB and angle POQ, they are equal to each other. So materials needed are compass, color paper, pencil, scissors. So now let us do an activity in order to prove this activity. So take a pink sheet of paper and blue sheet of paper and draw a circle of same radius. Cut out the circle. So now I am going to prove this activity. Mark a point that is A and we have to draw a chord here that is from A to B. We will mark the point B and we will make the same on the other side with points P and Q. We will mark the center O. And now we will join the line segment AO and OP and also join the line segment OQ and OB, forming a triangle. Now we have to cut out the triangle. Now I have taken out these triangles. Now I am going to place them on each other. So we find out they are equal to each other or congruent to each other according to the side congruence in which 3 sides of 2 triangles are congruent. So now I have proved my theorem. Thank you.
Thank you, Ashriya. Sir, please.
Sir, Anand sir, unmute yourself first.
You are in which class?
Sir, 5.
5 class. Very nicely you presented. And 5 class, you are proving the circle theorem. It is a great thing.
Thank you, sir.
Okay, can you tell me a small question? How many radius you can draw a circle?
Sir, infinite. We don't have any number for the radius of a circle.
Okay. So what is the relation between radius and diameter?
So the relation is that radius, if radius is multiplied by 2, then it is equal to the diameter of the circle.
Yes, yes. Very good. How many chords you can draw in a circle?
Sir, we can draw also infinite times of circle.
How many chords? How many chords you can draw?
Sir,
you know the chord?
Yes, sir. Sir, we can draw infinite number of chords in the circle.
Yes. So which one is the longest chord?
The diameter.
Diameter. Very good. Thank you.
Asreya Panda.
No, sir, Ashira Parida.
Oh, Parida. Okay. Sorry. So the presentation was very good, no doubt. But one question. You told me that you've written there is a area of circle equal to pi r square and the value of pi nearly equal to what is 20/7. What is the pi? I can understand that. What is actually the pi?
Yes, sir. The pi is used in circle in order to calculate, and pi's value has been calculated by dividing circumference divided by the diameter, because whenever in a circle, whatever the circumference or the diameter is, if we find out the value, it will always be an definite values like 22/7 or 3.14.
Okay, thank you. I understood now. And then one more doubt is there also. Well, you told that there were two triangles congruent. What is the triangles congruent? What do you mean congruent? I can understand. I know that equal, but you told congruent.
Yes, sir. The congruency means that it is not only equal, but it is equal according to the shape, size, and the length of that figure.
Good. Very good. Thank you.
Sir.
Thank you. Thank you, Asya. I think this is the last one, ma'am.
The last part, no, one more child is there. So the last participant is Aditya Aryan Satpathy. The code number is 252. The project name is Fibonacci sequence.
Mathematics is a subject that is full of wonder and is applied in our every moment in our life, and is also applied in our every activities. Fibonacci number is one of them. Good evening. I am Aditya Satpathy, going to speak a few lines on today's presentation, Fibonacci sequence and its application. So what is Fibonacci sequence? A Fibonacci sequence is a set of numbers starting from either 0 or 1 and that proceeds on the same loop, that each number is equal to the sum of preceding two numbers. For example, 0, 1. These are natural numbers. If we add these first two numbers, we get 1. If we add these two numbers, we get 2. If we add these two numbers, we get 3. If we add these two numbers, we get 5. If we add these two numbers, we get 8, and so on. This was first noted by the medieval Italian mathematician Leonardo Piscani, formally related to Fibonacci series. The Fibonacci sequence of numbers Fn is defined using the recursive relation method, that is, the Fn is equal to Fn minus 1 plus Fn minus 2. This is the recursive relation method. So what is Fn? Fn is the end term of the sequence, that is, the end of the sequence. What is Fn minus 1? Fn minus 1 is the n minus 1 term of the sequence. What is Fn minus 2? Fn minus 2 is the n minus 2 term of the sequence. So if we take an example Fn as F6, so to find the sixth term, we have to do F6 minus 1 plus F6 minus 2. So F6 minus 1 is the F5 and F6 minus 2 is the F4. which means the fifth and fourth terms. If we add the fifth and fourth terms, we get fifth term. That is 5 is equal to 8.
Fibonacci sequence.
Who is talking?
There are two
Abhiraj.
Fibonacci sequence, that is the recursive relation method, that is addition of the previous number to get the preceding number, and the golden ratio method. For example, the A plus B by A is equal to A by B, which is this sign. This means the phi is the sign of the golden ratio. So all are confused why I have done A plus B by A. A plus B by A I have done because in the example I have picked the A by plus B as A as the greatest number. So to find the golden ratio, we should always divide the greatest number with the sum of preceding and the previous number. For example, the 2 by 1. So to find the 2 by 1, we have to divide this 2 and we get 1, 2. If we divide the 3 by 2, we get 1.5 and etc. The application of Fibonacci sequence. The Fibonacci number gives the solution of certain enumerative problems as well as in the nature. In mathematics, the Fibonacci number is also a complete sequence. This means that every positive integer can be written as a sum of Fibonacci number where any one is the ones at most. For example, starting with 5, if we draw a right triangle with a hypotenuse triangle, if we take the length as 3 cm, 4 cm and 5 cm. So to find the hypotenuse triangle, 5 cm, 4 cm square.
Shreya Sahu, mute yourself. Shreya Sahu, mute yourself.
These petals are placed in a 0.618 quarter. This is a flower. These petals are placed in a 0.618 quarter. Application in human body. Our body has made in a golden ratio method. For example, from our shoulder to our elbow is 1, and from our elbow to our fingertips is 1.6. From our head to our belly button is 1, and from belly button to our toes is 1.6. Fibonacci number can be used in music, computer science like binary strings, and in optics. With this, I conclude my presentation. Thank you. Have a nice day.
Thank you very much. Sir, please.